Okay, so we have an upcoming climograph quiz, so I wanted to post a video review and notes about the upcoming quiz. So first off, I have in Canvas, there is some information about the upcoming quiz. It includes a link to the lectures where I go over climograph quizzes, and I'm going to also do a review of that in this video. I also have a link to a handout. Normally in a face-to-face class, let me go ahead and I have that open in this tab here. This would be a handout that I would give out in class, and you would take notes on this to study for the climograph quiz. Since we're not meeting in a physical classroom, what I'm doing is providing a PDF copy. If you're able to print it out and make notes, that would be great. If you don't have access to a printer, you could maybe open it on one screen, look at it on one screen and review the video on another. If there's anything else I could possibly provide that might help you take notes in a digital format, I'm open to suggestions as well. So just contact me if that's the case. But anyway, they're numbered here. They don't have the names attached to them. But you can see there are these different graphs. And hopefully you've gone through the lecture where we talked about climate classification and climographs, so you have a good understanding. These should not look unfamiliar. These should be familiar from the lectures where we went over these climographs. But I'll go ahead and review that information today as well. Another note about the quiz is that you will have to match. So there's 12 names here, 12 graphs here, and in the quiz you'll need to match the graph to their name. And the names in the quiz will appear exactly as they are here. So just so if you're making notes, these are the names that you'll want to be able to attach to each one of those graphs that are shown in the handout. All right, so let me minimize this. And so let's just recap a little bit about, let's just rewind a little bit. So we're talking about climate, which is the average of weather over time. And we're looking at the spatial distribution of climates on the Earth because it's a geography class. But these are some basic climate types. And how they're different from one another is that each region shares some characteristics in terms of temperature and precipitation. That's one thing we've learned, is that those are the two key elements of climate. And so what climographs are charts showing how patterns of temperature and precipitation over the course of a year. Now, a couple things to note. There is two sets of measurements, one for precipitation on one side. That is the measurement for these blue bars here. And another for temperature on the other side. That is for the red line here. The red line is for temperature patterns. The blue bars are for average rainfall. Also note that this is averaged. This is not like 1 year. This is like a 30-year average. So using a 30-year average, this is what on average temperatures are like both day and night combined together over the course of a year. And these blue bars are the average amount of monthly precipitation for each one of the months. It goes in order from January, February, March on through December. And we're using these graphs to help visually understand a little bit about these different climate classifications of the Köppen climate classification system. So we've gone over that in lecture. It's global scale, widely used climate classification system. And I'm sure you've gone through the chapter, seen this chart like this. It has broad categories, A, B, C, D, and E. On a map, the A's would be near the equator, the B's just above and below that. The C would be coastal areas in the mid-latitudes. The D would be more continental areas in the mid-latitudes. And the E would be the polar regions, like in Antarctica and Greenland. A are tropical climates because they're here near the equator near the tropics. B are the dry climates, deserts and grasslands. C are the mild mid-latitude climates. They're the ones that don't get so cold. And the D are the severe mid-latitude climates, the ones that get really cold in the wintertime. And the E are just straight up cold climates, polar climates, right? Here's a closer view of that illustration from the book. The major categories can then be divided into subcategories. So for A, tropical climates, We have tropical wet or rainforest climate, tropical monsoon, tropical savanna. And for the quiz, we're going to have all three of these. For the dry climates, the book kind of differentiates between subtropical and mid-latitude, but we're just going to focus on mid-latitude. And we're going to have one example of desert and one example of steppe. Actually, two examples of steppe. For one reason, because Fresno is a steppe climate, and I want to have an example that's Fresno and an example of one that's not Fresno, just so that we have a comparison. The next are C, the mild mid-latitude climates. And here we're going to have just two examples, actually two examples, but one for the northern hemisphere, one for the southern hemisphere. We'll have a Mediterranean example for the northern hemisphere and a Mediterranean example for the southern hemisphere. We'll also have a humid subtropical one for the northern hemisphere and one for the southern hemisphere. We'll skip marine west coast because these first two are really easier to differentiate between each other. And marine west coast is maybe not quite so much. And then we'll have one example of a D climate and one example of an E climate. For E, we use tundra, and for D, we use subarctic. All right. And this is a figure from the book showing the distribution of these specific climate types. This is pretty busy. There's a lot going on here. I also have a simplified map that I've put together with the A, B, C, and D climates all kind of grouped together into one color. And again, as we've talked about, these are climographs. So this is a climograph for Fresno. Fresno doesn't get that cold in the winter, so the temperature isn't that low. It gets pretty warm in the summer. It has a moderate amount of rainfall in the wintertime and hardly anything during the summer. So that the patterns that we experience here in Fresno, this is what they look like graphically. And one thing I'll note about climographs is that it was kind of too hard to do this. It's unfortunate. So I'm going to include some videos that talk about climographs, but in a face-to-face class, what we sometimes would do in classes, I might give you some data and a blank piece of paper with a blank climograph, and you have to use the data to try to create your own climograph. It's kind of hard to do that in an online environment. And one thing, but I'll just make this point. The point of that exercise is to tell you that if I just give you a raw table of data with temperatures and precipitations, your mind is not going to be able to make much sense of it. It's just a bunch of numbers. It's hard to really compare that set of numbers to some other set of numbers. However, when you display it graphically like this, and you can visualize the differences. So what we're going to be doing is doing some comparisons of one climograph versus the other. And if I just give you the numbers for both of those, it may not make much sense, but when you see them visually, it helps you understand how one climate is different from the other. So let's take a few examples here. And so this is the graph we just showed for Fresno, California. And we're in the mid-latitudes, 36 degrees north. We're well outside of the tropics. If you recall, the tropics extend to about 23.5 degrees north to 23.5 degrees south. Fresno is above that. As is Santiago, Chile, below that. So Santiago, Chile is in the southern hemisphere. Fresno is in the northern hemisphere. And these two other examples are more in the tropical zone that are nearer to the equator. And one thing I'll point out is that if one way you kind of know where you're at in the world is by the shape of the temperature graph. If the temperature graph is frowning at you, you see how this looks like a frown? Kind of goes down on the ends. What that's telling you is that it's colder in January, hotter in July, and then gets colder in December, like in Fresno. That is what temperature patterns are like in the northern hemisphere, at least up in the mid-latitudes. We have seasons. We have colder winters in January and warmer summers in July. Let's go to the opposite side of the world in Chile. Here, instead of a frown, it's a smile because it's an opposite pattern. Remember, their seasons are the opposite of ours. When we're in summer, they're in winter and vice versa. So here, it is warm. It is summer in January, and it is cold. It is winter in July. So that pattern is the opposite. So it looks like the smile versus the frown of the northern hemisphere. Now in between there, near, you know, when you get close to the equator, you don't have those seasonal differences. Remember that the tropics don't have that same amount of seasonality. So in the tropics, you either have like no change at all, like in this example, this rainforest or tropical wet example in Salvador, Brazil, or you might have some slight variation in this one for India, for example. You do have like two, you have kind of a double bump, but not the arc, or, you know, not the frown or smile that you have in when you get outside of the tropics. Okay, so this is a map showing where the A climates are. AF is tropical wet, also known as tropical rainforest climates. They're right here where the rainforests are, like in the Amazon basin, Central Africa, Southeast Asia. The AM are tropical monsoon climates. We've talked about monsoons before. And AW are the driest of the three. Those are the tropical savanna. Those are the parts of the tropics as we get a little bit drier, as we move away from the wettest part of the tropics. Those are the savannas. All right, so these are climographs for those three. The wet rainforests, or AF. Now, one thing about all three of these is they don't really have a significant temperature pattern. It's either straight or almost straight. So that's not the difference between these. The difference between these three is the rainfall patterns. Wet rainforest compared to monsoon has less seasonality, but it's constant. If you're in, this is like places right near the equator that are rainforest environments that have consistent and heavy amounts of rainfall all year round. Monsoons also have a lot of rainfall, but you can see the difference here. It's almost like it's flipping you the bird or something. You have the dry season and then a big burst of rainfall happening in the summer months. Remember, we've discussed monsoons. It's about the differences between the ocean temperature and the land temperature. So when the land heats up, boom, you have that big amount of rainfall. When the land cools down, the seasonal pattern reverses. And then lastly, savannas are the driest of the three. So savannas are the driest of the tropical climates. So here you can see that this has overall a lower amount of rainfall than either monsoon or wet rainforest. Next are the B climates. B are the desert climates, like in the Mojave Desert, or grasslands like in the Great Plains of the US. And if you look at the top one and the bottom two, maybe pause the video to guess which one is the desert. I guess I could pause here, right? So the difference between what really just moving here. If you notice that the top one here, hardly any rainfall at all. This is in Death Valley, California. It's a good extreme example of a desert environment. Now the difference between desert and steppe is that steppe has some amount of rainfall, and it doesn't matter what the pattern is, if it's winter rain or summer rain, there's more rainfall than in a desert. And that's why I'm using a Fresno example and a non-Fresno example to illustrate this. On the left and on the right, one of these is Fresno. Pause for a moment if you can maybe guess which one is Fresno. Okay, so hopefully you're understanding that when the bars are low, that's when you have lower rainfall. And if you're familiar with Fresno, you know that we have very little rainfall in the summertime. So this example is Fresno. This one, I believe, is in Texas. I think it's Perry, Texas. This one, they get more rainfall in the winter, but it doesn't matter if it's winter rain or summer rain. It matters because it's not as low as a desert, but it's not enough to be one of the wetter categories. It's what we call semi-arid climates. One for Fresno, recognizing that it's dry in July and August, and the other one that's not Fresno. Here's just kind of two extremes. This is a rainforest versus desert. And you can see the high amounts of rain, consistently high amounts of rainfall in the wet rainforest climate, and the very low amounts of rainfall in the desert climate. Okay, next are our sea climates. And sea include three types: Mediterranean, like here in California; humid subtropical, like the southeastern United States. So Mediterranean is more west coast. Humid subtropical is more east coast. Then there's one that's like higher latitude west coast called marine west coast. That'd be like what you get in Oregon and Washington. But we're going to focus on the red one, Mediterranean, and the orange one here, humid subtropical. The reason why I've chosen those two is because they're easy to distinguish from one another. And what distinguishes Mediterranean, and we'll get into the southern hemisphere part in a moment, but let's look on these ones on the left here. What distinguishes Mediterranean from other types of climates is Mediterranean is all about the seasonal pattern. Now, Fresno had a seasonal pattern too, but it didn't matter. The dry summer is the key characteristic of a Mediterranean climate. So here in the summertime, you have low amount of rainfall. That is what distinguishes Mediterranean from its cousin over here, which is humid subtropical, which both of these are wet, but this one is not a dry summer climate. This one is. And this is and remember that in the southern hemisphere, you have the opposite pattern. So this, I'm just going to jump ahead. This is Mediterranean in the northern hemisphere. Note the frown, right? This is Mediterranean in the southern hemisphere with the smile. Now, I said that Mediterranean climates have dry summers. However, in this graph here, there's higher amounts of rainfall in June and July. So how can that be a dry summer? If you like, pause and think about that. I'll give you a second. Well, the reason is because in the southern hemisphere, this is not when the summer is. The summer is like in January or December. Now, one way to think about this is if you were to cut half of this graph and paste it on the other side, it would look very similar to this other graph. In other words, this is the same graph, but 6 months off. I actually did this in Excel just to illustrate it. So if we kind of renumbered the months, if we started in, rather than starting January, but we started here in July, if we reordered the months 6 months off, it would look like this. So this would be like July through June rather than January through December. So now they kind of look like each other. But here this is July and here this is January. But we don't do it that way because we try to be consistent by ordering the months in the same way. And so this is what it looks like for the northern hemisphere, and this is what it looks like for the southern hemisphere. Remember, northern has a frown, southern has a smile. And likewise for humid subtropical, they can be fairly wet in the summertime. East coasts have warm water off their coast. That's why they get more hurricanes, if you recall. But it's not just hurricanes. It's just more summer rain in, summer storms, hurricane or not. So they get a fair decent amount of rain in the summertime here. And in the southern hemisphere, it's the opposite pattern where this would be their summer, and they also get a fair amount of rain there as well. Now, one thing I'll note, this thing about Mediterranean or dry summer climates. This is up here in Red Bluff, California. Northern California, kind of in this red zone, which is Mediterranean. They have a dry summer there, but it's considered a sea climate, Mediterranean, because it gets a decent amount of rainfall in the winter months. Now, note that Fresno, we're about where the F is, maybe a little to the right of that. We also have a dry summer. However, because we are considered a B or steppe climate, a dry climate, because we just don't have enough rainfall in the winter to qualify as a Mediterranean climate. So with Fresno, it's defined by the low amount of rainfall. For Mediterranean in Red Bluff, it's defined because of the pattern of dry summer. So even though we have that same pattern, our rainfall is so low that we're not considered Mediterranean. Now, if you were to drive up into, say, Auberry, or drive maybe 10-30 minutes into the foothills, you would be in a Mediterranean climate where you see the oaks and the other vegetation. But here in Fresno, we're not quite wet enough to qualify as Mediterranean. Next to our D climates, the geographic distribution of these is inside the continents where there's more severe. Remember, if you're away from the ocean, you have more severe winters. And that's what these are about. Places like Canada and Russia. One thing unique about these is that you find them in the northern hemisphere, not so much in the south, because the latitude that they're at in the north, if you kind of look down here, so if you look at 60 degrees north, is about where they are in the north, on top. But if you go down to the bottom 60 degrees south, there's not much land there. And these are what are called continental climates. You need a big landmass to have a D climate. So they're really a northern hemisphere only phenomenon. So what defines these? These have extremely cold winters because they're in a continent. They don't have the ocean influence that the sea climates have. So their winters are really cold. So I'll do a comparison in a moment, but while they have cold winters, they have warm summers. They're not super hot, but they are warm enough that, and specifically, they get over 50 degrees Fahrenheit. This is why I've kind of marked that off here. Because they get over that temperature during the summer, that makes them warm enough to have trees growing there. Usually it's very hardy trees that can survive the severe winter, but they do have trees. Might be helpful to compare C and D. So this is a C climate, this is a D climate. Now they're both in the northern hemisphere, they both have the frown, but look how deep that frown is in the D climate. And that's the point, that really low edge, that really deep curve means that it gets really cold in the wintertime. Summer's not too bad, but the wintertime it's very bad. Whereas sea climates, they're mild, they're influenced by the ocean, so they don't dip as far down. They are more, the difference between the cold and the height of the curve is lower than the tall curve of the D climate. And then lastly, we have our polar climates. By the way, this one is subarctic, but we can just call it the D. It's the only example we have of a D climate, so we're just going to stick with that. And lastly, we have our polar climates, including tundra and ice sheet. EF is ice sheet, ET is tundra, and the example I have is tundra. Tundra is not quite Antarctica, ice-covered stuff. Looks more like this. So tundra are places that are extremely cold but not consistently covered in ice. And ice sheets are the coldest places in the world, like Antarctica. But we'll use a tundra example here for comparison. Okay, and so we compared the C to the D climate. Now let's compare the D to the E. This is again that 50-degree mark, right? And one thing we noted is that the D climates get over 50 degrees in the summer. That allows trees to grow. Where the E climates, you notice that the curve does not make it over 50 degrees. And because it does not make it over 50 degrees, one thing different about the environments of the D and the E climates, tundra is treeless. And so you notice this open plain with no trees. The reason there's no trees there is because it's too cold for trees to grow. So between C, D, and E, comparing D and E, I mean, the precipitation looks pretty low, but on the other hand, when it's really cold, you don't have evaporation so much either. That's really not the critical thing. Between C, D, and E, the differences are in the temperature patterns. C are mild and relatively warm. The D are warm in the summer, but really cold in the winter, and E are just straight up cold, cold.